Number 13, the ability to taste certain substances, such as PTC, is also genetically controlled. People that can taste have the dominant trait, so can taste have the dominant trait, while non-tasters have the recessive trait. Suppose a woman who is a non-PTC taster marries a man who is a heterozygous PTC taster. Which Punnett square accurately demonstrates this match? Okay, so the very first step, what we have to do is figure out what are the parents' genotypes, what are their letters. Okay, so we know from the information that it gave us, right up here, the first thing we highlighted, if you can taste PTC, that's dominant. So down here, I'm going to make a key. A dominant T is going to mean you can taste. And then the next thing we highlighted about non-tasters, we said that they are recessive, so a small t. So no taste. Okay, so now we go back to our parents' genotypes. A woman who is a non-PTC taster, so she cannot taste PTC. When we look at our key, the only genotype that we can have for a non-taster is going to be homozygous recessive Ts. Because if there's a dominant T at all, that means you're a taster. And it says she is a non-taster. The man is a heterozygous PTC taster. Remember that heterozygous means different. So we have different sized letters. We're going to have one dominant and one recessive. So based on this, we can go through and figure out which Punnett square has these two parent genotypes in it. So let's look for one that has a parent with homozygous recessive. So right here we have a heterozygous and a homozygous dominant. That's not what we're looking for, so A is not correct. B, we have a heterozygous and a homozygous dominant, which is not what we're looking for. C, we've got a homozygous recessive right here, which is what we were looking for. And then the man, remember, was a heterozygote, which is also right here. And then D does not have that heterozygous recessive that we were looking for, which means it cannot be the correct answer. C was correct.